When it comes to the 7 rocky, roughly Earth-sized planets in the Trappist-1 system, the question on everyone's mind is, could they support the kind of life we find here on Earth? A new study may add another tick to the yes, possibly column. The 7 Trappist-1 planets all orbit their parent star closer than Mercury orbits the Sun. In Earth's solar system, that position would likely mean certain death for life, but the Trappist-1 star is much dimmer and cooler than our Sun, so there is still hope. 3 of the Trappist-1 planets appear to orbit at a distance where their surface temperatures could be right for liquid water, also known as the habitable zone. Trappist-1. How long would it take to fly to 7 planets system? This artist's rendition shows what the surface of a planet in the Trappist-1 system might look like. Credit NASA's Occultech. The new study looks at how much ultraviolet UV radiation is received by each of the planets, because this could affect how much water the worlds could sustain over billions of years, according to the study. Lower-energy UV light can break apart water molecules into hydrogen and oxygen atoms on a planet's surface, while higher-energy UV light along with X-rays from the star can heat a planet's upper atmosphere and free the separated hydrogen and oxygen atoms into space, according to the study. It's also possible that the star's radiation destroyed the planet's atmospheres long ago. The researchers measured the amount of UV radiation bathing the Trappist-1 planets using NASA's Hubble Space Telescope, and in their paper they estimate just how much water each of the worlds could have lost in the 8 billion years since the system formed. This artist's rendition shows the planets of the Trappist-1 system. Credit NASA's Occultech. It's possible that the 6 innermost planets identified by the letters B, C, D, E, F and G, pelted with the highest levels of UV radiation, could have lost up to 20 Earth oceans worth of water, according to the paper. But it's also possible that the outermost 4 planets E, F, G and H, the first 3 of which are in the star's habitable zone, lost less than 3 Earth oceans worth of water. If the planets had little or no water to start with, the destruction of water molecules by UV radiation could spell the end of the planet's habitability. But it's possible that the planets were initially so rich in liquid water that, even with the water loss caused by UV radiation, they haven't dried up, according to one of the study's authors, Michael Gillen, an astronomer at the University of Liège in Belgium. Gillen was also lead author on 2 studies that first identified the 7 Trappist-1 planets. It is very likely that the planets formed much farther away from the star than they are now and migrated inwards during the first 10 million years of the system, Gillen told Space.com in an email. Farther away from their parent star, the planets might have formed in an environment rich in water ice, meaning the planets could have initially had very water-rich compositions. We're talking about dozens, and maybe even hundreds of Earth oceans, so a loss of 20 Earth oceans wouldn't matter much, Gillen said. What our results show is that even if the outer planets were initially quite water-poor like the original Earth, they could still have some water on their surfaces. Follow Calico Field at Calico Field. Follow us at Space.com, Facebook and Google. Original article on Space.com.